Hey guys, I just wanted to do a little review of the Telegizmos 365 cover. This is the cover I have for my telescope. I put this cover on every morning when I'm going to leave the scope out. I prefer to leave the scope out for days on end as long as the weather permits. And so I keep the scope more or less protected from direct sunlight anyway by putting this cover on. It's a well-made cover. It's a nice cover. I bought mine from High Point Scientific, and this is the price at $150. It's an expensive cover, but it is in fact well made. Now, if we look at the information about the covers, the thing that I was particularly interested in is this inner liner. There is an outer liner that is acrylic coated woven polyester, and it feels quite waterproof. The inner liner is kind of an aluminum foil looking liner, and they speak of it here as a radiant barrier that provides radiant heat protection, effectively protecting your equipment from radiant heat buildup. Well, last year in the summer we had a day of 90 degrees, and I put a cheap outdoor thermometer up under the cover next to the scope, and it measured 120 degrees when the temperature outside was I don't know, maybe in the mid 90s. And so that led me to wonder how hot might it actually be getting, because that thermometer only registered up to 20 degrees. And so I bought a couple of little data loggers, temperature data loggers, fairly cheap. I think they're, I don't know, between $15 and $18 or something off of Amazon. Basically, they're intended to travel with foodstuffs and measure the temperature during the transportation period. So essentially what I did was keep one data logger, this one here, attached to Velcro on the back of the scope next to the camera. The camera is just off behind us here at the bottom of the screen. The guide camera is just above us. And then I took this data logger, once I was going to put the cover on, and left it outside and tried to avoid direct sunlight as much as possible. And what I wanted to do was compare the temperatures that these two data loggers saw over the course of what turned out to be a 5-day astro imaging period when I had the telescope outside. These data loggers are both set to record data at the same time, and they're recording the temperature at 5-minute intervals. And so here's how we upload the data into the computer.
All right, well, we've got the telescope in. Here are the data loggers. This one I had hanging on the back of a chair in the shade, so it was never under the cover, and this one was under the cover. Got the software that came with the data logger up, and so what we need to do is download or upload the data. It has a USB interface, and so we can just plug that in and create a connection to the device and upload the data. Next, right now, let's export this to Excel. And there it is. We have temperature in Fahrenheit. We have the time, and every 5 minutes it recorded the temperature. So that's the outside temperature. Now the temperature that was adjacent to the scope and therefore under the cover. And now let's export this to Excel. And we can stop recording on this device.
Okay, so now that we have the data in the computer, here's what we got. So here I took the set the data loggers up to record. This is on February 21st. So I'm inside at this period, setting them up to record and starting the recording process. And then I took the telescope outside, and the temperature began to shift from the indoor temperature to the outdoor temperature. And about 8:30 I started the imaging process, And as you can see, the camera sensor, which is these data points here, for each image I take, I get the camera sensor temperature as reported by the Canon DSLR temperature sensor, and it, as you can see, it rises as it heats up due to all the imaging and reaches an equilibrium, and then it just more or less follows the outside temperature. As the temperature continues to drop overnight, the temperature in the camera drops as well. Around the morning, I put the cover onto the before I go to work, I put the cover over the telescope, and not much happens here. The temperature over the day, as the sun rises, the day heats up, and I guess there are a couple of spikes here where direct sunlight might have got to the outdoor temperature sensor. But the sensor next to the telescope is under the cover. It's not seeing those spikes. But what is interesting is, and this confirms what I saw last summer, the temperature under the cover rises quite a bit. Now here the difference is only about maybe 15 degrees. But here's what I did. I noticed, and my imaging efforts were cut short by a significant dew problem, and so I put a fan on the front of the telescope to circulate air over the corrector plate to try to dry out the corrector without touching it. Here's what that looked like.
Hey guys, well, we had a lot of bad dewing up last night. I'm not going to put the lens cover on here. I'm going to let that dry out. I've put on a USB powered fan, so I just unplug the one of the USB cameras or mount, and then plug in the fan, and then I'll put the cover, the Telegizmos cover, on top of this, and this will circulate air up and around the where all the condensation is, and hopefully dry it out.
So with that USB powered fan in place and blowing air into the front of the corrector plate, this temperature difference turned out to be around 15 degrees at the worst case heating time at around 4:30 p.m. Then as the evening comes and the temperature starts to drop, I take off the cover and begin the imaging period for that evening. Once again, the temperature more or less follows the outside temperature, but it's about 30 degrees hotter than the telescope temperature. And these dips here represent periods when I would switch from one target to the next, and there would be a period where the camera sensor was allowed to cool down a bit before the imaging process picked back up. That morning I would put the cover back on, and we would again heat up, but this time I had the fan. I moved the fan from the front end of the telescope, attached it to the back, and had it blowing directly on the cameras, and which is very close to the temperature sensor. And here you can see maximum temperature during the day, which again is around 4:30, 4:40 p.m. There's about a 10-degree difference here between what's inside, what's measured outside in the shade, versus what's being measured next to the cameras. But again, I have the fan blowing directly on the cameras here. And these spikes here, well, that's just there's a period where I happen to have the outside sensor, and it would get a direct sunlight for a very short period of time, and that's what caused these spikes in the outdoor sensor. So I'm kind of ignoring these spikes and saying this is the blue line, with the exception of the spikes, is basically represents what the temperature would be in the shade. And so under the cover it's quite a bit hotter than it is in the shade. Now there's a 10-degree difference here with the fan, little USB fan blowing on the cameras. Here it's a 15-degree difference, but the fan was at the front end of the telescope, not the back end. And then I began imaging again, and as you can see, the camera sensor temperature is again 30 degrees warmer than the air temperature. After the imaging session is done, again I put the cover back on, and now the temperature rise. I didn't put the fan on this time because we had a cold front that blew in. As you can see, we dropped significantly here. So a cold front blew in, so I wasn't that concerned about the temperature under the cover. But here we're back to about 15 degrees, but it was very windy. In fact, it was so windy that the next day I didn't even bother doing any imaging. But there was quite a bit of wind, and that probably helped play the same role as this fan did by circulating air up under the cover and keeping things a little bit cooler. And then again, as we go through the day, the cover has been on all day here, and now we're coming up at the heat maximum temperature of February 25th, and now without the fan blowing, there's a good 20-degree difference here between the outside air temperature and the temperature of the telescope. And then taking the cover off again, doing some more imaging, and then collecting darks for the remainder of the evening here. And then finally, I brought the scope in earlier this morning. So this is the data that we pulled off the two temperature sensors, and you can see here that there is quite a bit of difference between the outside air temperature in the shade and the temperature next to the telescope. So I don't know what exactly they're talking about, this radiant barrier and helping to prevent radiant heat buildup. It seems there's a pretty good bit of heat buildup. Now, what I think I also learned here is that having the fan underneath the cover and circulating air next to the sensors, the cameras that I have back there, does help cut this temperature rise in half. Here it's a good 20 degrees, and here it's down to 10 degrees. And so I'm pretty sure I'm going to, if I use this cover in the upcoming summer, I'm going to keep a fan, and perhaps even a larger fan, circulating air up under the cover, because I just don't need the optics and the electronic components getting up to 130 degrees or whatever it might be during a worst case summer heat wave that we have here in Texas. Well, I just thought I'd take the so I guess my assessment of the Telegizmos cover is it's a well-made cover. It's I think it's certainly better than leaving the scope exposed to direct sunlight. However, if you're expecting the radiant barrier to prevent heat buildup under the cover, you're going to be surprised. There is a good potentially 20 to 25 degree difference that I've measured here. But however, using even a small USB powered fan can help cut that temperature difference in half. And so I would recommend that if you use this cover and you live in a hot climate, as I do, you might want to consider installing a fan underneath the cover to keep the air moving. All right, thanks for hanging in there, guys. Talk to you later.